Hi, good evening, everyone. My name is Catherine, and I am a clinical lab consultant with WAVE. Thank you for joining our webcast this evening. Tonight, we are so excited to have Dr. Paul Levine joining us, and he'll be sharing a few of his Ortho-K cases, so hopefully a little more challenging ones. And again, we are happy to have Dr. Paul Levine with us tonight. Dr. Levine is a fellow of both the International Academy of Orthokeratology and Myopia Control and the American Academy of Optometry, and is also an International Academy Certified Myopia Manager. He's the immediate past president of the board of directors of the American Academy of Orthokeratology and Myopia Control, and he's lectured both nationally and internationally on Ortho-K and myopia control. And with that, we can go ahead and get started, and I'll turn it over to Dr. Levine.
Okay, thank you. Thanks everybody for coming out and watching this presentation. They did want me to give you some complicated or advanced cases, which I tried to pick ones that I thought were kind of relevant. I stayed away from the minus like 30, 14 diopters of astigmatism nonsense that I don't think is going to do any of us any good. And actually, I really haven't done any of those. But I did pick some of the ones that I thought would be pretty relevant to what you're going to see in your practice. So I am going to present each case. I'll show you the pre-fit data as you see here for both eyes, but I'm really only going to just go through my process of one eye just for simplicity and time's sake. So this is a 15-year-old Indian female, and as you can see, this is a case with relatively, high myopia and high cylinder and a fairly large cornea. And the thing that, there's a couple things that you should pay attention to when you take on a new case like this, and or any case really, is, how close of a match do we have on our refractive cylinder versus our corneal cylinder. And so, you can see on that right eye that on the cornea, we're measuring about 2.73 diopters of astigmatism, and lo and behold, in the refraction, we have 2.75 diopters of astigmatism. So, this should not be a very complicated case. And the topographies that you're looking at here on the left of your screen is the tangential map, and on the right of the screen is the axial map. So, the axial map is really expressing a little bit more toward the power of the cornea, and of course the tangential is more toward the shape. And there's a very defined cap, as you can see, with a fairly deep blue moat around it. So you're going to anticipate some probably higher E values with an eye like this. But before I actually even think about designing a lens, the first thing I do is look at the elevation map. And to me, the elevation map is kind of the key to understanding the relationship between a lens and the cornea. So, I think y'all know this, but the elevation map essentially is showing how different that cornea is from a sphere, and from a best fit sphere. And those numbers that you see, each one sits 4 millimeters from center. So in other words, at an 8 millimeter chord, or at 4 millimeter semichords, I want to know what the elevation is of that cornea. And you can see that horizontally in the flat meridian, our elevation is higher than the best fit sphere, and in the steep meridian, it is steeper than the best fit sphere. So this is a very toric cornea, and it's also a very symmetrical cornea. So, we talk about RSIM, and we talk about GSIM, and we talk about freeform, and a case like this, to me, an RSIM lens is never going to work, because you're going to have a lot of flooding and in the alignment zone at 12 o'clock and 6 o'clock. There's just no way to get the same alignment in the horizontal as it is in the vertical meridian with 70 diopters of difference. 70 microns of difference, excuse me. And so And then the second thing we look at is the symmetry. So the fact that this is a super symmetrical cornea means we're going to probably do really well with a GSIM lens. So that's what I'm going to choose for this case. And so what I did here was I just kind of took you through me designing. So, I measured the HVID at 12.1. I generally set that at about 95%, so that's 11.7. And I just jacked up the target power of the lens, the plus, it defaults to 125. I jacked it up to a +2 because this is a pretty high, minus case. And so if you notice to the right of the screen, you can see the E values. Let me pause this for a second. I apologize, the video actually started back to the beginning. But if you look to the right of the screen, you're going to see the Ks and you're going to also see the E values. And you'll notice that in the flat meridian, the E value is very high at 0.7. So what that means is the cornea is going to flatten out pretty quickly in the periphery. And when you have a high E value like that, the chances are your alignment curve is going to probably be a little too steep. It's going to dig in a little bit too much to that real flat alignment. So I'm going to decrease the overall sag of this lens by dropping that reverse curve by about 10 microns. And I'm going to do that in the horizontal meridian only. And I'm going to keep the steep meridian, which has a lower E value, as it was originally laid out. So in other words, I just lifted up the alignment zone a bit in the horizontal. And for us old guys that are used to the old looking Wave software, that's the same thing as clicking up on the blue ball 10 times. So what I did here was I used the modification in the new system by lowering the reverse curve by 10 microns in the horizontal meridian. But in the olden days, I would have just switched it to 1/2, clicked on the blue ball, I'd click it up 10 times in the horizontal meridian. So this was the design that we came up with. And so what you're looking at here on the left of the screen is the horizontal meridian, and on the right of the screen is the vertical meridian. Because we had almost 3 diopters of astigmatism, you can see that there's a big difference in the reverse curve in the steep meridian versus the flat. But if you look just under or just above the tear film profile, you're going to see that the power of +199 and the base curve of 9.26 is the same. So in other words, this is using a spherical base curve and a toric periphery. And this is what the lens looked like on the eye. So you get to see what that looks like. It bounces around a little bit when they blink, and so one of the things I like to do is see what kind of influence the eyelid has on the lens. So I pull the lids away and I can kind of see what relationship that, the fit has with that lens and that cornea. And, that looked pretty decent to me. It could be a little tight still in the alignment area. It's a little hard to tell, but it looks like the right size and it looks like it should be a decent lens. And I'm going to spare you the 1 day and the 1 week because I'm almost never going to make a change until I've hit about 3 to 4 weeks. And if you want to write that down, you should do so. I think the biggest mistake that we all make is we make changes too fast. And especially in a high SIL, high minus lens like this, it's going to take some time. But once we hit a month, I'm only at 20/60 plus. I'm still under correcting in the flat meridian. I'm under correcting in the steep meridian. Overall, I think this lens needs to be stronger. And I'm a little, we've managed to cut down about 4 diopters of sphere, but only 1 diopter of cylinder. So I decided that it was time to treat this thing more like a toric lens, in that I wanted to get more aggressive in the steep meridian. This is what the maps looked like after that 1 month, and you'd generally be pretty happy with that. So we know we got good centration. We know the lens was fitting decently. But if you look down to the lower right under the difference map, you'll notice that the power is only reading -4. So we were looking to decrease this thing by, more like 5 with almost 3 diopters of SIL. So we can see that we're undercorrecting here a little bit. And that's just what the axial looked like, just to kind of get a better view of the changes that we made and the overall size of the treatment zone. So we got to lens 2, and here's where I went with what we call an oval treatment zone. And the reason why I did this is because in that steep meridian, I had almost 8 diopters to correct, right? 7.5 diopters or so. And in the steep meridian, you know that vertically corneas are a little bit smaller, and there's a lot of power to deal with in there, and sometimes you can get a little bit more aggressive with a smaller treatment zone. So what I decided to do was leave the 6.2, 6.8, red ball, blue ball in the horizontal meridian, but in the steep meridian, I cut that down to 5.662. And you'll see what that looks like in just a second. I also didn't jack up the target power just yet. I just went up to a 150, just because I wanted to process this thing and I wanted to get it through this first, phase of the lens design process. So now you're going to see, and I don't know how to do this in the new system any fancy way, so I use the old method, which is I'm on 1/2 modification, and I clicked the red and the blue over 6 times. So now I have a 5.662 in that steep meridian. And in the flat meridian, you can see it's back to a 6.268. The other thing that I did, just like before, was I went back to that flat meridian because of the high E value, and I dropped that down by about 10 microns. And then this is the new lens. And then just because I thought there could be some flexure going on with such a high cylinder, I increased the center thickness to 0.26 from my kind of standard 0.24. And now you'll notice, if you look at the very bottom of the screen where it says diameter, you can see that in the horizontal meridian on the left, I'm at 6.268. And in the steep meridian, vertical meridian on the right, I'm at 5.662. So now an oval treatment zone. And also, just by doing that, without actually manipulating the power or moving the red ball up or down at all, you'll notice that on the left, I've got a power of plus 199 with a 9.26 base curve, same as we had with the first lens. But the new power in that steep meridian is now a plus 4.1 with a 9.83. So I'm really jacking up that Jessen factor in that steep meridian by simply making the treatment zone a little bit smaller. And this is what that lens looks like on the eye. So, once again, I'm thrilled with that. I think it looks great. But, sitting up in my chair with our chin on the chin rest, blinking and breathing and not sleeping, you never really know what's going to be until you get a look at that thing after they've been sleeping in it. So definitely an improvement. We've got down to 20/40 and with a -50, -75, and coming from a -5 with almost 3 diopters a cylinder, that this is a very happy patient. Unfortunately, Dr. Levine likes to do things a little bit more aggressively, and he's quite never satisfied, sadly, because I probably should have just left this thing alone. But waivers like to tinker, and that's what we do, and I just knew I could do better. So I did ultimately go back to the drawing board, but I will show you, here's my tangential difference maps and my axial difference maps. So we get to lens 3, and I'm thinking, all right, I just need to go a little bit stronger on this lens. So I'm going to make a couple of minor modifications. The first is, and I started off with the same lens, I'm just going to take the base curve and I'm going to flatten it across the entire lens by a half diopter. So in other words, making the lead stronger by minus 0.5. Except that I thought I maybe wanted to go up more like 0.6, 0.7, but I couldn't figure out how to do that in the new system. So I just went back to the old and I clicked on the red button and I went up a couple more clicks. I also wanted to adjust to improve the sort of central applanation, if you will. I just lowered that horizontal meridian by another 5 microns. And then I went back to the steep and I actually tightened that up by 5. So sometimes when you have these toric corneas, I find that it really works well in wave, and a bunch of us wavers do this kind of routinely, which is in 50% mode, lift up the horizontal alignment a little bit and drop the vertical alignment just a little bit. So let's see what that turned into. So this was, just how that looks. As you can see, now the total power at plus 2.37 at a 9.36 is quite a bit higher than it was. If you remember, it was a 1.99 plus 199. Now I'm at 237. And you can see in the steep meridian that we've also jacked things up a little bit and flattened that base curve all the way down to a 10. And so here's what that thing looks like. And you can see it looks like I'm kind of bleeding into that lower alignment curve area, but I think there was just a little bit too much fluorescein and flooding, because once I kind of pulled the lids off, the alignment curve really did tighten up. And you can actually appreciate the oval treatment zone on that video. But alas, I told you I should have left it alone at lens 2, but I didn't. And you all should learn from my mistakes. But at any rate, I overcorrected this time and didn't really do too much to fix the astigmatism. And by the way, you can't always mold out every ounce of astigmatism. So I did go back to the drawing board yet one more time. And I'm not going to show you the process because literally all I did was steepen the base curve across the entire lens. I changed the fitting relationship not at all. The only thing I did was I just steepened up the base curve, and you can see the numbers are back to not quite as flat as it just was on that last lens. And this is what that sucker looked like. So once again, and by the way, I'll talk about the left eye in just a second. So that looks great. I love it. Looks perfect. Should have stopped at lens 2. But this did get me to plano minus 75, axis 15. She was 20/25 uncorrected, really happy. So the thing I wanted to talk about with the left eye, human beings tend to be pretty symmetrical. And so pretty much most things that happen with one eye do tend to happen with the other. And so I made all the same changes with both eyes, and we ended up in the same place with both eyes, which ultimately was a pretty happy patient. So that was just an example of where I had to get a little bit more aggressive in that steep, real high minus periphery. And so, that's where we're at with that case. So I'm going to jump into a couple of much more quick cases. Everything I'm about to show you all kind of made it work with one design. And the reason why I'm showing you this case, because this case is not that special. You can see there's only minus 275, a sill of sphere, a little bit of sill, relatively close match, cornea versus refractive, a little bit big in the HVID. But the reason why I chose this case was because that's a pretty flat cornea. As you can see, the flat meridian is 40.61 and 40.86. So, some people are afraid of flat, and I hear the same question all the time. Can you treat a X amount of power with a X flat cornea? And I think the bigger question is, are you dealing with a normal cornea, or are you dealing with an oddly shaped, wacky cornea, or a big mismatch between cylinders? So just being flat should not stop you from being successful. And if you look at the elevation map, on this one, you can see that this is a relatively spherical cornea. I mean, we go from 0 to -13 tops. So this thing is a relatively spherical cornea. And so you'll see, I did this one a while ago, but you can see that this one was done in the old format. And I'm just gonna basically adjust the diameter. And I'm actually going into RSIM because I know it seems crazy. Nobody seems to want to use RSIM, but rotationally symmetrical lenses on spherical corneas do work. And this was the lens that I created for that. I literally made no modifications. It was a one and done deal. And this is, again, you're looking at horizontal or flat and steep meridian, horizontal and vertical meridian, because the lens is exactly the same. You know, the tear layer profile looks a little bit different, but ultimately, you know, this patient was 20/25 plus with a little bit of cylinder in that against the rule, which, by the way, if I go back a little bit, you know, you can see that there was really very little cylinder to begin with. So this probably overcorrected just a little bit, which is why I'm kind of inducing a little bit of against the rule cylinder. But, you know, the patient was really happy, and I didn't think there was any reason to make a change on that. You can see what the tangential difference map looked like. Well-centered, beautiful treatment zone, nice red ring. This is what it looked like axially. So just a very quick example of fit in a flat cornea. I actually want to jump past this case. Because of time, want to leave enough time for questions. So I'm going to jump to this one. This was a pretty cool case, I thought. So there's a 9-year-old kid, boy, and low minus, low cylinder, big axial length. So, you know, this, and a flat cornea. Flat cornea and big axial length means watch out. This kid's going to progress fast. He's already a -2 by 9 with K's under 41 and an axial length approaching 26. This kid's in for a big ride. So it was important to get this right. You can see from an elevation standpoint that it's a pretty symmetrical cornea. So I'm already thinking this is a GSIM lens. And indeed, that's what I created. So I made a GSIM lens, and you can see that it is a spherical base curve because there's a +148 both sides with an 8.92. And this is what I want you to understand. When Wave decided to deal with this cornea, what Wave did was it averaged even, I mean, I always choose do not average astigmatism, but Wave is still averaging the astigmatism. And so if you take the 40.74 and the 42.96 and you average that, you come to an average of about 41.85. Now, let's just talk about the flat meridian for a second. The flat meridian is -2.25. Okay, so let's take that average K, the 41.85, let's subtract out the 2.25, and then let's subtract out the 37.83, which is the base curve, 8.92, that Wave chose for me. You can see it over on the right in that little black box. And that left a difference of 1.77. So in other words, the flat meridian, the horizontal meridian, is being overcorrected by 1.77 from the average K. If we actually go through the same process in the steep meridian, because there's 3 diopters to deal with in the steep meridian, and we take that same 41.85 and we subtract out the 3, we get a 1.03 Jessen. So we have a higher Jessen factor. We're overcorrecting more in the power meridian that has less power, and we're correcting less in the meridian that has more power. So that almost seems counterintuitive, right? Okay, so we're going to come back to that. The next thing I did was I reran this lens in free-form design. And when you run it in free-form design, there's no more averaging astigmatisms. And so when we, so now if we do the same math and we take the 2.25, we take the flat meridian, 40.74, we subtract the 2.25 diopters, and we subtract out the 38.09, now we only have a Jessen factor of 0.4, okay? So in my mind, that's not enough to correct that flat meridian. And if we go to the steep meridian and we do the same math, we have a correction of 2.13 over. So what I'm trying to express to you, and I want to just show you, I want to talk about this a little bit more. What I'm trying to explain is by using a GSIM lens on this cornea, by using a GSIM design on this eye, okay? Because if you actually look at the corneal cylinder, I mean, there's almost 2 diopters of difference there, but yet I only have 0.75 in the refraction. So if I do a freeform lens, well, I'm going to significantly undercorrect the flat meridian, and I'm going to significantly overcorrect the steep meridian. But I can't do that. If you go back to the GSIM design, now a 1.77 is kind of like the perfect, like 175 is kind of a perfect Jessen factor for a -2.25. And I don't want to fully correct the steep meridian because it's 2 diopters higher than the flat meridian, yet I only have 0.75 diopters that I have to fix. So by relatively undercorrecting the steep meridian with that 1.03 Jessen factor, that should give me a decent refraction post-fit. So if this is confusing, I'll try to explain it in question and answer a little bit better. It was hard to sort of write this the way I wanted it to come out, but I'm hoping that you all grasp the concept. And if you notice, he was a little bit of a fussy one, this guy. But you'll notice how beautiful that fluorescein pattern looks, if I do say so myself. It's a lovely lens in a GSIM. And you can see how beautiful that looks too. He was 20/20 with a +50 refraction. So what we ended up doing was not fully molding out that 2 extra diopters of power in that steep meridian, but because we had a lesser Jessen factor, as you can see right here. So when I did a GSIM design, again, I was kind of overcorrecting the flat meridian, but sort of undercorrecting the steep meridian. If I had used a freeform design, I would have significantly undercorrected the flat and overcorrected the steep, and there would have been all sorts of induced astigmatism. So you need to always think about this stuff when you're deciding on how you're going to design lenses. I'm going to stop talking in just a second after I give my favorite organization on the planet a quick plug, which is the FAAOMC. And if you guys aren't members of it, would you please consider joining? We're doing some really cool and really awesome things. And to be honest, we need support and we need members. And the more we can build that up, the better off we're all going to be in the long run. And like I said, the FAAOMC's got a lot going on, and there's a lot coming. So with that, I guess we could probably open up the floor to questions now.
Yep, that's great. Thank you so much. I do have a couple questions prepared. And just a reminder to everyone, there should be a text box on your GoToWebinar screen where you can enter questions. So please feel free to still enter those in if those come up. And if for some reason anyone missed any part of the webinar, we will also have it posted within a week or so on Wave Academy. And Dr. Levine, yeah, I have a couple questions here if you're ready for that.
I'm ready.
Awesome.
I'll do my best.
So this was just over center thickness. You mentioned just going higher
Mhm.
for flexure.
Yeah.
And I believe in the example you showed 0.26, the question was, do you ever go any higher than that, or is that about what you
No.
use?
I've never really gone any higher than that. Sometimes if you're um, uh, with non-ortho K lenses, sure, it goes higher a lot, especially if you're designing sclerals or corneal lenses, especially for hyperopia. But in an ortho K lens, I've never gone any higher than that. I've never really found any necessity to do so.
Okay.
Oh,
And the
and by the
minimum,
way,
okay.
I would say 99% of the time I use a 0.24.
Okay, perfect. I was just going to ask that. Great.
Mhm.
And that's the minimum that you go for center thickness?
Yeah.
Okay. And the next question was about choosing diameter. When you're choosing your lens diameter, how much do you have a standard that you're typically subtracting from your HVID?
Um, what I do is I take the HVID, I do as best I can to find what that is with my topographer. The display on my MedMont topographer often doesn't allow a perfect horizontal measurement, so it ends up being slightly diagonal. And then I typically will multiply that number by 95%. So if I have a 12 millimeter cornea, I just say 12 times 0.95 equals 11.4, and that's my diameter that I choose. Sometimes if I have a very high cylinder case, like more than 3 or 4 diopters, I might go up to 97 or 98%.
Okay, perfect. And another question was, are there any instances where you do an initial design with an oval optic zone?
Not usually, um, because there are so many variables to troubleshooting, um, that I do really try to keep it simple. I do try to start off with what I think is the most straightforward and simple approach. And then if I'm not quite getting where I want to be, that's where I'll probably entertain that kind of thing. Um, if I have, let's say, if I have a -3, -4 axis 180, I might jump right to an oval. But most of the time I won't.
Okay, that makes sense. And another question again about lens thickness. Do you have a preference that you use for the edge thickness of the lens?
I do. Ever since I started doing this, I use the because Ken said so method, and so um, Ken Mahler taught me to use a point 0.3, and that's what I've used ever since. I almost strictly use a point 0.3 edge thickness.
Okay, perfect. And those are actually all the questions that we have that came through. So that was fabulous. That was a great presentation. And anything else that you wanted to go over at all?
Um, well, let's see.
Mhm.
I, no, not specifically.
Okay.
I will. I'll just kind of throw a couple of little pearls out there, if I may.
Yeah.
So I think the best. You're only going to be as successful as the quality of your topographies. Um, you know, so I know that everybody on this call knows this, and I know that everybody on this call has a decent topographer. But you really should take your own topographies for the baselines. You can let your staff do all the post-fit, topographies, but I really think you need to be the one to take 4, 5, 6, however many it takes, till you get really good Myers, really good centration, lids out of the way, no shadows, no goobers. And I actually will label it right then and there, patient still sitting in the chair, baseline. Like I've already decided which of the multiple topographies I've taken I'm going to use. Um, and I take a quick look at the elevation map at the same time just to make sure I'm happy with it. And so I think that's really vital. I also think it's important, and I think maybe some of us forget to do this, to calibrate your topographer. You probably should calibrate that thing at least, maybe once a week. Every Monday morning, just make that part of your habit, because they do go out of calibration. And sometimes you can be off by a few microns, and that might be enough to kind of derail one of your cases. And then, like I said to you before, the last thing is really don't make hasty changes. Unless it's a complete train wreck, like let that thing go for at least 2 or 3 weeks before you consider making any modifications to your designs.
Yeah, I agree. It's super important. Okay, so that about brings us to our time. So thank you so much to everyone who attended and asked questions. Again, we'll have the recording up. And thank you again to Dr. Levine for a great presentation.
You're welcome. Thank you for having me. It was really my pleasure.
Thank you so much. And so with that, we'll go ahead and conclude tonight's webinar. And on behalf of WAVE, have a good evening, everyone. Thanks.